Hello, so today we are going to do this problem called Encode and Decode TinyURL. So it's part of Leetcode April Challenge. Basically, we are trying to build a TinyURL shortening service. A URL shortening service, basically, we give it a URL and then it returns a shorter version. With the base URL is always the same, but the rest can be just some code that represents the URL, a code that is unique to the URL. And we want to implement a class that does the encoding and decoding of those URLs. Okay, so there is no restriction on how we can encode or decode. We just need to ensure that a URL can be encoded to a TinyURL, and that the TinyURL, when passed, also can be decoded to the initial URL. So that's pretty much it. And so we have two functions, encode and decode. The encode gets the longer URL, which is this one, and decode gets the shorter one, which is this one. Okay, so that's pretty much it. Yeah, so all Leetcode I think does is checks that we are able to decode an encoded URL, right? And so that's pretty much it. So let's see how we can solve it. So the simplest way to do it is just to have increasing numbers represent each URL that gets passed to encode URL in the order they get passed in. So what I mean by that is that, for example, the first call to encode, we'll just make it appear like this. The second call, we can give it 1. The third call, we can give it 2. And with this way, because we are always increasing, the URLs will be unique and we'll be able to decode, right? And so with that, we can just save the tiny URLs in an array, right? And each time, basically, the length of the array would be what's encoded here. So basically, what this would mean is that we'll have the base. So we'll have the base URL as this. Right, so this would be our base URL, and then we'll just have, maybe when we initialize, we will have a list of URLs, right, that is empty. And so when encode is called, we will just have something like this, right, the first time. So, and then if it gets called again, we'll just do this. And what is this? What is this here? Right, this is just the URL position, right? So URL position is exactly what we add here. So this would be just plus the URL position. Okay. Now the URL position is just the length of the URLs minus 1. That's the position of the URL. Now to decode, right? How do we decode, right? So here in the URL we will append the code or the short URL. We can call it code. So if this is the code, then we'll just append the code. And so when we want to decode, it's very simple. We can just extract the URL position, right? And then we can do URLs at that position, right? Because when we inserted it, that was its position in the URLs array. So this is a very simple implementation. Let's do it. So we need to initialize our list of URLs. Okay, and here to encode, what we need to do is we need to append, right? But before that, we need to get the URL position. So our URL position is going to be, let's append actually before. So when we append here, then URL position is. Yeah, so that's the encoding part. Now we just need to return the URL, which is the base, plus the URL position, which is a string, right? So that's the first part. Now for decoding, as we said, we just need to get the URL position, which we can do by just splitting by this and then getting the last part, right? So if it's split by this, then the first part will be this, the second part will be this, the third part will be the URL position. So we can just do that here. So our URL position is going to be the short URL. And then we need to split by this and then get the last element, which is the URL position, And that way we can just, for the long URL, we can just return URLs at URL position. And that should be it. So let's run this. Okay, so if I forgot to initialize with the base string, which is just this. Okay, so here it's a string, we get back a string, right? Because it was part of string, so we need to convert it to an int to get a position. So this would be int to get an integer position. Okay, so now if we submit, okay, so that passes test cases. Now this one here has a couple of bad things with this implementation. First, like our URL can be really long. Let's say once we fit all the 6 integers, right, then we will start counting again, and then after that, so the numbers can be really okay, so another disadvantage of this solution is that if we get the same long URL, then we will decode it to a different URL. So let's say we get google.com on the first call to encode, then it will be assigned position 0, and so the URL will be tinyurl.com/0. But if we do it, if we call it again and call encode the 5th time with google.com, then we'll get maybe 4 here instead of the same tiny URL that we got initially, right? So there is that also. So how can we improve it? So one way we can do it is just have 2 maps, one that holds the as keys the long URL and as values the short URL, and another that has the reverse, so that each time we can put encode, we can put to your long URL the short URL, and for decode we can pass the short URL as key and get the same long URL. That way also in encode we can check if the URL exists already, we won't override it. Okay, so that's the solution that we'll be implementing here. Let's do it. Yeah, so the first thing we need to do is initialize our, so we'll leave the base as it is since it doesn't change, but we'll initialize 2 maps. One is long to short, so the keys will be the long URLs, and the other would be the reverse. So short to long, okay? And now when we want to encode, what should we do? So first we need to construct our short URL. We'll do that a little bit later. But once we construct it, we'll check if the URL, only if it doesn't exist, that we'll add it. So that way we avoid creating a new code for the same URL. And so here we'll check if it's in. If it's not in it, then we will add it. And so the key will be long URL for this one. And then a similar thing for short, except for short, the key would be the short URL and the value would be long URL. And that way in decode, we can just return the, since we get past a short URL, so let's call this actually short URL. So here we will just be able to say short to long and get the, using the short URL key, get the long URL value that we assigned earlier. Now for encode, we need to return the short URL, so we can just return it like this. Okay. Now how do we construct the short URL in a way that doesn't have the disadvantages that we mentioned with numbers, right? So here you can see in the problem statement, it asks us to do like a combination of, a random combination of lowercase letters, uppercase letters, and then numbers, right? So how can we do that? Let's just jump in the terminal here and see. So Python has this ASCII letters. Okay, maybe I typed it wrong. I think it's 2 I's, yeah. Import string first and then do that. So this gives us all the lowercase and the uppercase letters. Okay, and then it has also digits that gives us all the digits. So we can just take a random from these two. So for example, let's say our characters would be just a combination of the ASCII letters, right? letters, and then the digits. Okay, and that will give us all of them. Now what we can do is use, in Python there is this random that gives us a choice. So it will just give us a number, a random thing from this list. And since we want something of length 6, we can just take it 6 times, right? So what we can do there is just say, and then we can concatenate it to get something like this here. And so what we can do is just this. We want to do it for 6 times, so let's do for a range of 6. And then what we want is to make it a string, so we need to join it, because here it's a list. And so you can see we get something each time, a random combination of letters and numbers, right? So this is what we can use here. And so we could just go here. This would be our short URL. This would be the last part, right? But we need to append the base URL. Okay, and that should be it. Okay, we didn't define chars here, so let's do it. And so let's assign it here as well. And so that would be, we said ASCII letters plus digits, and each of them from string. And let's import both string and random. Okay, I'll submit. Okay, so that passes test cases, and this is more like the format that TinyURL does. Okay, so yeah, so in terms of time complexity, this one here, Encode, it's constant space, it's constant time here. Same thing for Decode, but in terms of space, we are using Oven, and is the number of calls to encode. Essentially, we are using Oven space. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.